Today, we are going to talk about a fire caused by a gasoline tank which was overfilled during a pipeline receipt. Tank fire prevention and firefighting professionals can learn much from this video. It should be of interest to anyone who works in the petroleum industry. Hello, I'm Philip Myers of PEMI Consulting. The footage is poor in terms of image quality compared to today's standards, but the content is better than almost anything produced today. It's an amazing tutorial on tank fires because it reviews how a serious tank fire is reported in the public domain and then does a review and a post-mortem critique. My friend and mentor, Dave Blomquist, who is one of the great fire protection engineers, developed this video. He mentored me and helped me to improve tank fire protection standards at various points throughout my career. He is the source of the content that you are about to see. Pause the video and see if you can answer these questions. This is the beautiful Honolulu area. Unfortunately, I'm going to mar this picture with a tank overfill and fire that occurred in August 1980. I have broken the video up into sections because it is longer than the average 2-minute attention span of today. But you can come back and watch the sections per your schedule and patience. Here is the terminal today, 42 years after the incident. Note the layout and consider how you would fight the tank fire. In fact, today's video is about tank firefighting, but it is unique in many ways. This photo was taken after the incident, and you can see the devastation at the terminal and obvious business interruption. But much worse, the property damage was accompanied by 2 fatalities. When an event like this occurs in the U.S., there is always going to be litigation. While any fire in a terminal can escalate to involve many tanks, what is unique about the overfill is that it is a prolific generator of flammable vapor clouds and can be ignited from hundreds of feet away, as was the case in this incident. Few other spill scenarios can generate the deadly vapor cloud. This is Section 2, Incident Overview. My background has primarily been in fire prevention through design, but in my previous job I always participated in tank fire discussions when these events occurred throughout the world in our operations. I also participated on these API firefighting and prevention documents. See if you can answer these questions and if you are familiar with the content of these documents.
A fire occurred in Chevron USA's Honolulu marketing terminal. Let's look at what caused the fire and what happened during it. A floating roof gasoline tank was overfilled, causing vapor to drift to the electrical switch room of the plant next door and ignite. Tragically, 2 employees were in the vapor cloud when it ignited. They received fatal burns. The combined efforts of fire departments from the city and airport of Honolulu, the Navy from Pearl Harbor, and the Air Force from Hickam Field extinguished the fire. Chevron employees, drawing on what they had learned at a supervisor's fire protection course, assisted the fire department officials in directing the successful attack.
This is Section 3. Pause the video and consider these questions. Can you answer them as you watch this overview that was reported in the news about this incident?
As you watch, please consider, are you prepared to respond and control a fire like this until it can be extinguished or burns out safely? Let's pick up the action reported by the news team of KGMB-TV in Honolulu.
Workers at Pier 12 heard a booming explosion shortly before 10:30, and in the few minutes it took us to run from Grosvenor Center, raging balloons of flame were shooting hundreds of feet into the sky, and thick black smoke was billowing thousands of feet above Ivalai. The gasoline fire at Pier 24 was so intense we could actually feel the heat from dockside at Pier 12.
Cameraman Cliff Watson and helicopter pilot Erwin Malsman were airborne as the fire raged out of control. The billowing black smoke was visible for many miles. 2 tankers, which were in port, were ordered out of the harbor. Police, meanwhile, blocked off Nimitz Highway from River Street in the downtown area to Guayacamilo Road in Lower Kalihi. Ambulances were sent to the scene to stand by. Hospitals were on the alert for more casualties. People within several blocks of the fire were asked to leave. News personnel, including reporter Elisa Yadao and cameraman Ray Muse, were told that they remained in the area at their own risk.
Battalion Chief Henry Sir was with the first company that arrived on the scene.
All you got here was just a whole ball of flame. I don't know how it started or what, but man, it looked bad.
A Chevron worker who was next to the tank when it exploded said he heard a boom and then saw flames. Initially, he said it looked like between 5 and 7 tanks caught fire. He said the first explosion set off a chain reaction, and flames, heat, and fumes spread through the area. Most of the tanks, he said, burned on the outside, and those fires were put out easily by responding fire companies. The tank that kept on burning was on fire inside. Isolated spot fires alongside that tank kept flaring up, caused by fuel leaking from ruptured pipes. The tanks that did not burn were sprayed continuously with water to keep them from rupturing. The 2 men critically injured in the fire are Herman Ayat and Tony Lozano, employees of They were reportedly within 100 feet of the Chevron tank when it blew up. The men are at Queens Medical Center. KITV cameraman Rodney Otani was also taken to Queens for minor injuries. He was treated and released. At about 12:45, it looked like the blaze was close to being brought under control. Assistant Chief Frank Kaho'ohanohano was in charge of firefighting operations.
As of now, the fire is contained to that one particular tank, and there's no fire spread on the bottom. I think the fire can be put under control within a half an hour. I have to check that out.
That was about 1 o'clock. Shortly after that interview, the fire flared again. Cameraman Don Cozono and reporter Leslie Wilcox pick up the story there.
With the worst thought to be over, firefighters worked on keeping the flames contained. That was when 2 of them were injured, Mackay of the burning tank.
This is Section 4. The unthinkable happens. This is truly shocking, but thank goodness the 2 firefighters who were completely engulfed in gasoline flames were not injured. Think about why as you watch this section.
Cameraman Cozono happened to be videotaping the area when the unforeseen happened. The voice you hear will be his, calling for help as he records the scene.
Hey, come over here! Hey, come on! Get over here! Hurry up! Hurry up, guys, burning!
Amazingly, Kenneth Yamamoto and Captain Henry Kaalekai walked away from the accident. They were doused with water and taken by ambulance to St. Francis Hospital. Both were released soon afterward, and Kaalekai was later seen back at the fire.
Well, I saw a few firemen fighting, keeping the area under control, and then these flames started building and came close to them, and one of them turned around to run, and he fell right in a pool of diesel.
And what did you see?
He went up in a ball of flames, and then his friend came over and pulled him out, and the fire went out right away, but he was really scared.
It was shortly after the injuries that the top of the tank once again spewed high flames. The floating roof of the tank had flipped over and dropped down into the tank. Looking back on this, Assistant Chief Kaho'ohanohano said it made the fire easier to get under control. There was no longer the roof to contain the heat. Firefighters could spray water and foam directly on the gasoline. City firefighters praised the work of military units there, especially the brand new Hickam Air Force Base P-15, one of the world's biggest fire trucks. Throughout all of this, Chevron officials were saying little, except that they did not know what caused the explosion and fire. Several Chevron employees told KGMB they had been threatened with dismissal if they talked with reporters about what they saw. Assistant Fire Chief Kaho'ohanohano said that more than likely the 5.5-hour fire was the result of an accident, but the matter will be investigated. Leslie Wilcox, KGMB News.
This is Section 5, the analysis and critique of what was reported by the news. Pause the video and consider these questions to test your understanding of terminal fires.
Now let's go back and look closer at some of the action. When the tank was overfilled, vapor drifted with the wind and soon found its way into the switch room where it ignited. Flames then followed the vapor back to the tank. At first, the fire only burned at the top of the tank and on the ground, where spilled gasoline had accumulated before draining away. Excessive use of water by firemen soon caused flooding and floated burning gasoline through a large portion of the tank impounding basin. Next, the spreading fire heated piping and loosened flange bolting, causing leakage of gasoline and other products into the fire. These leaks were sprayed with foam, but the foam didn't have any effect on the flange fires. Training could have taught the plant operators and the firemen that foam is not effective for burning liquid sprayed under pressure, even though it may be an effective agent to extinguish a spill fire. To extinguish a pressure fire, either shut off the fuel source or use dry chemical directed toward the source of the leak. We need to review the initial attack on this fire. 2 high-capacity water monitors were used. As Linda Coble reported, the tanks that did not burn were sprayed continuously with water to keep them from rupturing. While it is always good practice to cool piping and equipment that is exposed to fire to reduce further damage, oil storage tanks are in little danger of rupturing, whether they are cooled with water streams or not. 2 types of tanks were exposed to fire for nearly 4 hours: floating roof tanks and cone roof or fixed roof tanks. In both types, the steel shell of each tank remained cool below the level of the liquid inside. Just like a kitchen tea kettle, the metal sides get no hotter than the liquid contents. Above the level of the liquid, the shells did get hot, red hot in some cases. Inspection after the fire found 5 tanks with shells buckled, but the heat from the fire affected the tank shells only above the level of the liquid. Whether sprayed with water or not, storage tanks do not rupture and spill their contents when exposed to fire. For a tank to explode, there must be a flammable mixture of vapor and air confined inside. Then it must be ignited. First, floating roof tanks. Not one floating roof tank exploded during this fire because there was no space for a vapor-air mixture to collect. The roof floats on the surface of the liquid, and while the shell of one tank got hot enough for the sealing space between the floating roof and the shell to catch fire, there was no explosion. A little foam from streams directed at the main tank fire extinguished that seal fire. Now about the safety of fixed roof tanks. A fixed roof is attached to and rests on the top edge of the tank shell. Thus there is a confined space between the liquid inside and the roof. Even though this fire did heat lube oil stored in one fixed roof tank enough to release vapor, there was no explosion. Because with the tank full of vapor, there was not enough air left for the vapor to burn or explode inside the tank. It is important to point out a safety feature in the design of a fixed roof tank. If an explosion did occur, the roof would tear loose from the top of the shell and vent the explosion pressure. The roof-to-shell attachment is made purposely weak so it will fail before any other joint in the tank to prevent release of its liquid contents into a fire area. One final point about tank fires that Leslie Wilcox reported.
The floating roof of the tank had flipped over and dropped down into the tank. Looking back on this, Assistant Chief Kaho'ohanohano said it made the fire easier to get under control. There was no longer the roof to contain the heat.
It would have been much easier to put out a fire in the narrow sealing space between the floating roof and the shell than to extinguish the entire tank after the roof sank. When the roof sank, about 2 feet of gasoline had burned away. At that time, firemen may have been able to apply foam into the seal space gap between the roof and the shell by shooting a stream of foam against the inside top edge of the shell from the top of an adjacent tank. If firefighters guard against flooding the roof and successfully fill the roof seal space with foam, a tank fire can be extinguished with the roof still floating.
We now have Section 6, Lessons Learned. Consider these points as we review what happened.
I think it's time to review what we have just learned about planning a tank fire attack. First, use cooling water sparingly. Cool piping, flanges, and valves, and if flame is licking against other tanks, water is helpful if it can be applied where the flame is touching the steel. If not, it has little value. Remember, water used indiscriminately can do more harm than good. Water can break up foam covering a spill which can then burn. A good rule to keep in mind is, if you can't see the foam blanket, don't trust it. Second, extinguish ground fires. Let spilled liquid drain away from the tank. Cover any remaining burning liquid by gentle application of foam. Extinguish pressure fires using dry chemical. Third, extinguish the tank fire. Determine the required foam application rate for the area of the liquid surface burning. Apply foam as gently as possible until the fire is out. For tank fires, fluoroprotein-type foam seems to be most effective. Use care not to flood the floating roof with water or foam. Let the liquid in a full tank flow by gravity or pump it to any other tank, or let the tank burn until the level is low enough so foam can be deflected off the tank shell into the seal space. Keep in mind, too, if the fire cannot be safely extinguished, just cool surrounding exposures and let the tank burn out after pumping out all the liquid possible. Cameraman Kazono's vivid firefighting action shots demonstrate some important lessons for personal safety during firefighting. Let's look carefully at the action. The men are fully protected by firefighting turnout clothing, which may have saved their lives. But are they standing where they can easily retreat if anything goes wrong? Are they standing outside the gasoline spill area? The answer is no to both questions, and this is why the men were in danger. Both nozzlemen have set a fog pattern and are using aqueous film-forming foam. There is good teamwork as they watch out for each other. The man on the left moves his hose to protect his fellow firemen as flames get close to them. Notice flames under the piping where the foam layer is broken as foam drips off the piping. As the spray pattern from the hose on the left swings toward the fire, the spray breaks the foam layer and splashes burning gasoline toward the two firemen. Face to face with fire, they lower their nozzle to push the flames away. Their spray stream breaks the foam blanket and again splashes burning gasoline. They turn to run and kick gasoline into the air, so now they are enveloped in flame. Both trip and fall. One gets up, still in the midst of flame, then falls back. The other scrambles out and rushes to help as his buddy rolls out over piping to high ground. They both walk out as the foam reseals over the gasoline and the fire begins to go out. Fortunately, neither man was seriously injured. What are the lessons from this dramatic scene to help fight fires safely? Wear protective clothing. Avoid entering a pool of fuel. Apply foam gently. Deflect the foam stream off tanks, pumps, or the ground at the near edge of the pool of fuel. Don't disturb a foam blanket. Minimize use of water. Avoid flooding and spreading a fire. Always have a way out. Not yet mentioned is the need for a pre-fire plan. Some important elements of a plan are: first, list emergency telephone numbers. You should include fire, medical, and mutual aid as well as company management. Next, list duties of each person who is expected to respond to an alarm. Include emergency escape or evacuation. Then designation of chain of command, including public fire departments. Equally important are fire training and hypothetical drills that include public fire departments. The last two items are important to develop with the public fire department to assure good relations and clear communication during an emergency. A successful plan is one prepared, then tested in cooperation with local fire departments and mutual aid groups. Training and hypothetical drills will pay off because through them you will be prepared to safely extinguish almost any fire, even one as difficult as this one. It may seem that this report has been unduly critical of the firefighting efforts. The facts are, the knowledge and skill of the firefighters did succeed in extinguishing this fire without serious injuries during the firefighting. As to the mistakes, they provide valuable lessons for all firefighters.
I have a few concluding remarks. First, the principles outlined in this video for the most part are as true today as they were in 1980. A few things have changed, however. For one, there is a drive to fluorine-free foams. These behave differently than conventional AFFF foams. Training is more difficult because of the potential environmental issues. A useful resource is the API Foam Transition Guidance published in October of 2020. Second, pre-fire planning for each tank and each chemical or fuel is essential for the plan to be effective. Did you notice the firefighters on the catwalks and on the tank tops? Fall protection should be considered before any event occurs. Finally, anytime new terminals are constructed or major upgrades considered, tank spacing and access should be carefully thought about. In fact, I am on a task group that is showing that the current NFPA tank spacing rules may not be adequate for all situations. Thank you.